13.1 is the time value of money. I'm going to be working through some problems using the formulas that we already discussed. The first problem asks us, if I invest $5,000 at 2.5% interest compounded quarterly, how much money will I have after 6 years? I know from the words compounded quarterly, I'm going to be using the compound interest formula. First, I'm going to go over the information I know I was given. I'm looking for A, the amount at the end, the final amount. I'm given P, the principal amount of $5,000. The interest rate is 2.5%. I'm going to write that as a decimal, so I'll move over 2 decimal places, or I can divide by 100. Compounded quarterly means that M will be 4, because quarterly implies 4 times a year. N is found by multiplying M, which was 4, times the number of years. So 4 times 6 is 24. I plug those into the formula, getting A equals $5,000 times 1 plus 0.025 divided by 4, all raised in the exponent to 24. I'm going to type that in my calculator. I need to be careful of how I type it in. Every calculator is a little different, so you're going to have to play around and see how your calculator wants you to type in the exponent of 24. And then the final line is my answer, $5,806.46. I'm always going to round to 2 decimal places in this chapter. Our next problem has us depositing into a retirement account. This time, we want to know how much money we are going to need to deposit in order to have $500,000 in the future, 30 years from now. So instead of solving for A, I'm going to be solving for P. And unfortunately, the only way to determine if my problem is like the first example I did or like this is just reading through and looking at the context that it's given. In this case, we want to know what's going to happen in the future. Again, I've listed out the information that I know. I know I want $500,000 later, so I'm looking for P. My interest is 0.05 when I write as a decimal. Again, I'm compounding quarterly, so M is 4. And N I get by multiplying 4 times the years, which is 30. Plugging into my equation, the same formula that I used in the last problem, but this time the $500,000 will be on the left of the equal sign. This can be a little tricky because it takes more steps. What I'm going to do is solve as much as I can on the right-hand side of the equation. So I'm going to type in, starting with the parentheses on the right-hand side, 1 plus 0.05 divided by 4, the parentheses, and the 120 in the exponent. That gave me the long, nasty decimal place that you see in the third line. I'm not going to round this. I only want to round when I get to my final answer. It's okay if your calculator doesn't go all the way as many decimal places as mine does, but you do want to make sure it goes out at least 5 or 6 decimal places or your answer will be off. So what I have in the third line is $500,000 is equal to that nasty decimal place times P. I need to know what P is. So to get rid of the multiplication, the times, I'm going to divide by that nasty decimal place. And that's what you see in the fourth line. $500,000 divided by 4.440213229. Then I can get my final answer by typing that in the calculator, and this time I can round to 2 decimal places to give me what P is when I need to deposit now. For my last example, I'm going to be using a different formula. This time I'm going to do the compound continuous. Anytime I see the word compounding continuously, I'll be using the PERT formula. Or anytime that you see inflation mentioned. Inflation always uses PERT. So in this problem, I have coffee that currently costs $1.25. Inflation determines what it's going to cost in the future, just based on money and cost of things going up. It's the same story as when you hear your grandparents talk about how Coke only used to cost 5 cents and now it costs $2 for the same amount. That's inflation, and a little bit of exaggeration on their part. So this time I'm going to still list my given variables. I'm looking for A again. I want to know what's going to happen in the future. P is $1.25, R was 2% or 0.02, and time was 25 years. Remember, when we're using this formula, we have E, but that is a set number. It's not a variable. E is 2.71 and then continues on. It's a button on your calculator that we have to be able to find. So if you look, I plugged in all my numbers. I have 1.25, E, and then in the exponent, I make sure and put parentheses around both the R and the T. That's very important that your calculator knows both of them are in the exponent. So you're going to find where your E button is on your calculator. Most of the time you'll be given parentheses with it. If not, please make sure to use them. And as always, I'm going to round to 2 decimal places. If you're not getting the right answer, the first thing that you need to do is check and make sure you're using your calculator appropriately. Good luck.